Hey everyone, today I'll be doing 242 valid anagram. You're given two strings, S and T, and you just have to return true if they're anagrams or return false if they're not anagrams. So what is an anagram? An anagram, if a word is an anagram of another, it means that that word can be rearranged to equal the other word. Or in other terms, they have the same exact counts of characters. So if you have anagram and this word that is not a real word, you have these two words, which is the first example. Let's count the first word. We have 1A, we have 1N, we now have 2A's, we have 1G, 1R, we now have 3A's, and we have 1M. And we go to the next word, and we have 1N, we have 1A, we have 1G, we now have 2A's, we get to the R, we have 1R, we get to the A, we have 3A's, and we get to the M finally, and we have 1M. If you look, these frequencies are the same, 3A's, 1N, so forth and so forth. Therefore, they are anagrams. So you can solve this kind of however you want to. There's many ways you could solve this problem actually. You can actually sort both of the strings and compare them if they're equal. That's fine, but that's n log n. What if they're really long strings, right? So you can actually do this better than n log n, and that is do exactly this method here and count the frequency. So you can do even this way two ways. You could have two hash maps, right? And then just go through all the characters we look here, and it can only contain lowercase English characters, so we could go through all 26 characters, just make sure that the values in both hash maps are equal, and that'll work too. Or we can do this the cool way, which is you only need one hash map, and you can see if they're balanced, right? So if we subtract all the T characters and add all the S characters, at the end they should all be 0, because it should be equal balance. Because if you have 3 A's here in S, it'll be +3. But if you have 3 A's here, it'll be -3, so it should end up 0. So we'll do that way, because I kind of like that way, and it's interview friendly. So we'll have this be like, we'll call this frequencies, and this will be 26. So this will stand for the 26 characters in the lowercase English alphabet. And then we will fill that up. So we'll go through, and then we'll do an edge case too. If S and T aren't equal in length, then we know they can't be anagrams, because there will always be an imbalance. So we'll do that at the top here. So if s.length is not equal to t.length, let's just go ahead and return false immediately. And then we'll have our frequencies, and we can proceed with our plan. So we can go int I is equal to length, and we can use this I to go through both of the strings at the same time, because we know they're the same length at this point, right? So we'll do exactly what we said. We'll increment for S, and you can do this by, to get the character at S, you can go like this. So you go s.char at I, but to actually index in these frequencies, because these are only like, they can be indexed 0 to 25, right? You can actually offset the character by A, because A minus A is 0, which will correspond to 0 in this index. So you can do that exactly by doing frequencies s.char at I. You may know this trick already. I'm only explaining it because somebody may not know the trick. Let's copy it down, do the same for T. So we'll change this to T, but instead of plus, we'll go minus. So if you see what we're doing here, really all this means, to break this down in case you don't know, is we're getting the character at I for S, we're offsetting it by A, so it should be 0 to correspond to A, 25 to correspond to Z. We're incrementing it for S. This just reads as counting S's characters, and this is decrementing T's characters. So at the end here, they should really all be 0. These should all be 0. So we're going to do exactly that. We're just going to go for int frequency in frequencies. If frequency is not equal to 0, then we are going to return false immediately, because we know it's imbalanced. If we get to here, which basically means we made it through all the characters and they're all balanced, we can just return true. And then that's pretty much it for this. Let's submit it, and then we can talk about time and space. Looks pretty good. Time and space, this is constant. space. The reason being, even though we are creating a new array and filling it up, it can only be 26 because it's lowercase characters. So this is constant space. This here is n time because we have to go through the string, and the string can be theoretically infinite. Here we're just going back through these 26. So really we're left with the biggest values, which are time being O of n because we have to go through the strings, and space being constant space because we don't use anything besides this 26. And hope you enjoyed. Hope this was helpful. Thanks for watching.